Find the general antiderivative of g of t equals the quantity 1 plus t squared over the square root of t, and h of theta equal 2 sine theta minus secant squared theta. As of now, we don't have any rule to find the antiderivative yet, so we will have to guess and check. To guess and check, it is better to have the term by term. We can't find the antiderivative of the numerator and the denominator separately because, again, there is no such rule to find the antiderivative, not yet. And even if we do that, we won't end up with the correct answer. So it is best to rewrite this function. The common denominator is the square root of t, so this is 1 over the square root of t plus t over the square root of t plus t squared over the square root of t. We then simplify this by rewriting the radical as power. 1 over t to the 1/2 power plus t over t to the 1/2 power plus t squared over t to the 1/2 power. And we simplify each term. 1 over t to the 1/2 power is t to the negative 1/2. T over t to the 1/2 is t to the 1/2 power. 1 minus 1/2 is 1/2 plus t squared over t to the 1/2 is t to the 3/2. 2 minus 1/2 is 3/2. Now that we have three separate terms, we find the antiderivative of each of the terms. The antiderivative of t to the negative 1/2 is t to the 1/2. But if we check this, we have the derivative of t to the 1/2 is 1 over 2 t to the negative 1/2. Since we don't have that factor 1 over 2, we would multiply the reciprocal in the guess. 2 times t to the 1/2. Again, if we check this, we rewrite 2 and then we find the derivative of t to the 1/2, which is 1/2 t to the negative 1/2. 2 and 1/2 canceled out, so this is the correct antiderivative of t to the negative 1/2. Similarly, the antiderivative of t to the 1/2, we guess that it is t to the 3/2, but when we find the derivative of this, we have 3 over 2 times t to the 1/2. We don't have that factor 3 over 2, so we would multiply it 2 over 3, the reciprocal of 3 over 2. And we check this. We bring down the factor 2 over 3. The derivative of t to the 3/2 is 3/2 t to the 1/2. 2/3 and 3/2 canceled out. Give us back t to the 1/2. So this is the correct antiderivative of t to the 1/2 power. Similarly, the antiderivative of t to the 3/2 is t to the 5/2, and this is because using the power rule, when we differentiate, we subtract 1. Finding the antiderivative, we would add 1. But by now, we know that if we were to guess this, we would introduce the factor 5 over 2. T, 5 over 2 minus 1 is 3 over 2. But again, we don't have that factor 5 over 2, so we would multiply 2 over 5 to prevent 5 over 2 from happening. To check this, we bring down 2 over 5. The derivative of t to the 5/2 is 5 over 2 times t to the 3/2, and 2/5 times 5 over 2 canceled out, leaving us with just t to the 3/2 only. So yes, this is an antiderivative of t to the 3/2. When we're done, we just simply add a constant c and rewrite this as the capital G of t, which is the antiderivative of the little or the lowercase g of t. In the online homework, we might not need to write g of t because this might be provided to us already. For h of theta equal 2 sine theta minus secant squared theta, we have two terms, so we would need to find an antiderivative for each of the term. What it is so that when we take derivative, we have 2 sine of theta. First, we guess. Our guess is that the capital H of theta is 2 cosine of theta minus tangent of theta, because the derivative of tangent of theta is secant squared theta. But again, with any guess, we need to check this. If we differentiate capital H of theta, we have 2 times the derivative of cosine is negative sine, and the derivative of tangent of theta is secant squared theta. The derivative of a constant c is 0. We have negative secant squared theta back. We have 2 times negative, not positive. So in order to prevent that factor negative 1 from happening, we would first multiply negative 2 instead of positive, and then we check this again. This time, h prime of theta is negative 2 times the derivative of cosine of theta is negative sine theta. The derivative of tangent is secant squared theta, and the derivative of c, a constant, is 0. This is positive 2 sine theta minus secant squared theta, so they checked out. The answer, or the antiderivative for h of theta, has to be the capital H of theta minus, don't forget that minus sign, minus 2 cosine theta minus tangent theta plus c. And this is the final answer.